Okay, find the Cartesian equation for each of the following parametric forms. Okay, so when it asks for a Cartesian equation, what they want is an equation with just y and x involved. Okay, so they don't want the parameter t, okay, involved at all. Just y, possibly in terms of x, or just an equation where y and x and nothing else. Okay, no other variables, no other letters such as t in there. Okay, and of course the name Cartesian is in reference, isn't it, to the x and y axis Cartesian coordinate grid that we are used to. Okay, so when you see the word Cartesian, you just got to think just an equation involving x and y. So in this case here, okay, what we need to do is sort of like eliminate, okay, t, okay. So we've got y and x just involved. This one's quite straightforward because what we can do here with the first one, we can rewrite it, can't we? So we've got x equals 4 plus 2t. So we can take that 4 over the other side and we have x minus 4 equals to 2t. Okay, and we can do the same to the second one. We've got y equals to 1 plus 2t. Well, we can take that 1 over, can't we? So it will become y minus 1 equals 2t. Okay, so I've got expressions now for 2t in terms of x and in terms of y. So because these are both 2t, both equal to 2t, I can say now that x minus 4 is equal to y minus 1. Okay, so in other words, y minus 1 is equal to x minus 4. And then I can tidy this up a little bit. I can take that minus 1 over. So I get y equals to x minus 4 and then plus 1. So y will equal to x minus 3. Okay, so there is my Cartesian equation, okay, where I've just got y and x involved and we've eliminated that parameter t. Okay, right, let's look at the second one. This one's obviously a bit more complex. Now what I can do to eliminate t here is from the first equation. Let's deal with that one because that one we can rearrange this to get t equals. Okay, that's what I'm going to try and do here. Not so straightforward there because it's t squared, and you know if you were to get t equals there, you got t squared, haven't you? But if you were to get t equals, you'd have to square root, and you'd have plus or minus, and so we don't want to go down that road. Okay, let's just rearrange this one. So I've got x equals to 2t minus 1. So if I bring that minus 1 over, it becomes a plus 1. Okay, so I've got x plus 1 equals to 2t. And then to get t on its own, because I'm timesing that, I need to take that 2 over, and I'm going to divide. So now you can see I've got an expression for t in terms of x. Okay, so because I know t is equal to this, what I can now is substitute this value of t into the y equation. So I can say, look, sub into y equals 1 minus t squared. Okay, so therefore y will become 1 minus, well, if my t is equal to this, now because it's t squared, I've got to square all this. So I will have that, yeah? And you'd be expected to sort of maybe tidy this up a bit, make it look a little bit nicer. So we've got 1 minus, well, when I'm squaring this here, you can square top and bottom, can't you? So you can do x plus 1 all squared and square the bottom. So 2 squared is 4. Okay. Now I've got this. What I'd perhaps be tempted to do then is to times through by 4. Okay, so if I times through by 4, I'll have times everything by 4. That'll become 4y. That'll become 4. And then you getting rid of that 4 then there. So you just have x plus 1 all squared, so I can write that as x plus 1, x plus 1. So then let's multiply out this bracket. So let's put that minus there. Let's put a square bracket. If we multiply that out, first I get x squared, out as I get x, in as I get x, so that's 2x, and then last I get 1. So now I've got 4y equals to 4. Let's apply that minus to all this. Minus x squared minus 2x minus 1. And I can simply then write this as 4y equals to, well, 4 minus 1 is 3. So 3 minus x squared minus 2x. Okay, so we can't simplify that any further, and it's fine to sort of leave it like that now. Now I've got myself a Cartesian equation where the parameter t is now eliminated, and I've got an equation involving just x and y. Okay, right, let's look at one more. So with this one here, again, just as we saw before, I wouldn't sort of go anywhere near this in terms of trying to rearrange it and get t equals, because if I had t equals, I've got a square root, plus or minus. Let's not go there. Let's deal with this here. So let's try and get t equals from here. And this one's okay. This one isn't too difficult to do. Okay, there's a few ways you can approach this. One really good way of doing this, right, to get t equals, is first of all, write x as x over 1. Okay, because x is the same as x divided by 1. Yeah, and then if we flip this, so x over 1, flip it, so it becomes 1 over x. Okay, but then you've got to flip that side as well, so you have 1 plus t over 1. Okay, so in other words, 1 over x is equal to 1 plus t. And then if we take that 1 over, I have 1 over x minus 1 is equal to t. Okay, and then finally then you have to substitute that in there, so sub in. So you have y equals to, well, you've got to square it, so we're going to square this and then add on the 4. Okay, so again, it's a case of multiplying this out. Okay, so you have 1 minus x minus 1, 1 over x minus 1, 1 over x minus 1, that's the 4. So when you expand here, the first 1 over x times 1 over x, well, 1's on the top and x times x on the bottom is x squared. Out as minus 1 over x, in as minus 1 over x, that's minus 2 over x in total. Plus then minus 1 and minus 1 is plus 2. Okay, so no, sorry, minus 1 times minus 1 is plus 1, and then plus the 4 in the end would be plus 5. So there is your Cartesian equation in terms of x and y.